Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class P. This is for session U9. Alright, for number 1, if y is equal to 3x plus 2 and 3x plus 4 is equal to 9, then y is equal to... So here, you have y is equal to 3x plus 2, and you're actually given 3x plus 4. Well, to turn 3x plus 4 into 3x plus 2, you have to subtract 2 on both sides. So once you do that, you'll get 3x plus 2 on the left, and that's equal to 9 minus 2, or 7. And 3x plus 2 just so happens to be equal to y. So you know that y is also equal to 7. That's choice E. All right, next for number 2. Points J, K, L, M, and N all lie on the same line. Now, L is the midpoint of JK. Then the length of JL is 3. If K is the midpoint of JM and M is the midpoint of JN, then JN is equal to... All right, so they all lie on the same line, so we can just draw a really long line. And here we know that L is the midpoint of JK. So I don't really know where J and K are, but I know that L is right in the middle. That's what a midpoint means. It cuts JK into 2 equal pieces. And now JL is equal to 3. So that means that L to K also has to be equal to 3. All right, now for the next part, K is the midpoint of JM. So you have another point M, which is over here. And now JK is equal to 6, because 3 plus 3 is 6. So that means that KM also has to be equal to 6. And last but not least, M is the midpoint of JN. So to go from J all the way down to N, M has to be the midpoint, and here, point J all the way to M is going to be equal to M all the way over to N. So here 6 plus 6 is equal to 12. So that means that M to N is also equal to 12. And last but not least, you want to know the point J all the way over to N. So that's going to be 12 plus 12, which is choice E, 24. So all these lines add up to, or line segments add up to 24. All right, so again, the key is just midpoint, and midpoint is the middle. All right, next one, number 3. For all x is greater than 0, which of the following expressions is equivalent to 7 times the square root of x cubed plus 6? All right, so you have to pretty much just simplify this. And these aren't like terms, so you can't really do anything to it. The only thing you can do is simplify the square root of x to the 3rd power. So remember, when you square root a number here, you want to look for the biggest perfect square factor. So if you find the biggest perfect square factor, you can then split the square root into 2 pieces. That's like this, the square root of a plus times b is the square root of a times the square root of b. So this is actually one of those key laws of exponents that you have to remember. A square root's an exponent of 1/2. So here you know that x cubed is equal to x squared times x, and x squared is a perfect square. So you're going to rewrite the entire expression to 7 times the square root of x squared times x. So you got to add 6. And now you can split the square root into 2 separate square roots using this law. So that will give you 7 times the square root of x squared times the square root of x plus 6. Now the square root of x squared, assuming x's are positive, the square root of x squared is just equal to x. Because x is a positive number, it's not a negative number. Remember, a negative number squared is positive, so the square root of that positive number won't ever be a negative number. So here we know that x has to be positive, so we can We don't have to worry about that. So that means that the square root of x squared here just turns into 7 times x. And you still want to multiply by the square root of x, then add 6. And that is choice D. So here you just have to use this law as well as this general idea to simplify a square root. You want to look for the biggest perfect square factor. All right, next for number 4, if x raised to the, I'm assuming this is a negative 1/3, is equal to negative 1/9, then x is equal to. So here you have a couple things. You have a negative exponent and you'll have a fractional exponent. So let's do the fraction first. If you have an exponent, a base b raised to the a over c power, the a represents, the numerator represents a power, and the c represents a root. So this is equal to b to the a power to the c root, or the c root of b raised to the a power. All right, and then the negative exponent is b raised to the negative first power. It's really a reciprocal. It turns into b 1 over b. Or you're going to have b raised to the negative a. That's equal to 1 over b to the a. So it means reciprocal. So these are the two laws of exponents that you're going to have to use. So here we have x raised to negative 1/3. Well, what you can do there is you can use this law here to turn this into a positive exponent. That's going to turn to 1 over x to the 1/3. And this is equal to 1 over x raised to the 1/3 is really the cube root of x. Remember, it's a denominator, so it's a root. And that's equal to negative 1/9. So that means that here, the numerator is equal to 1. So you can actually just cross multiply here. This negative 1/9, you can have the negative in the numerator or in the denominator. It doesn't really matter. Here you're going to want to cross multiply. That's going to be 1 times 9, which is just 9. That's equal to negative the cube root of x. So here, if you divide by negative 1, you know that the cube root of x has to be equal to negative 9. You just move the negative to the other side. Let me rewrite that. So the inverse of the cube root is the third power, the cube. So that's going to give you x, and you have to do negative 9 to the third power. So that's negative 9 times negative 9 times negative 9. Now, 2 of them will give you 81, but 81 times negative 9 is negative 729, which is choice A. All right, next for question number 5. 2 high school track and field teammates, Olga and Vanessa, are entered in a 4,000-meter race, which is to be run in 200-meter laps around an indoor track. Olga runs at a race at an average speed of 250 meters a minute, while Vanessa runs at an average speed of 200 meters a minute. At the moment Olga completes a race, how many laps behind is Vanessa? All right, so here we have a distance question, so it's D equals RT. Distance equals rate times time, and we know that because you have a race that's distance. You have a rate, meters per minute, if you look at the units here. And last but not least, of course, is time, which is how many minutes it'll take them to run. So here Olga completes, for Olga, you have D equals RT. The distance is 4,000 meters. That's equal to her rate, which is 250 meters a minute. and you want to multiply that by time. So we don't know what the time is, so we can call that t. So here, to solve for t, we can divide both sides by 250 meters per minute. So here on the left side, you have 4,000 divided by 250. Right, and that's 16. And that's going to be 16 minutes. All right, so here, if you look at the units, you know the units is minutes because it's in meters divided by meters per minute, which means you have to do keep, change, flip, which is meters times minutes over meters, and meters will cancel out. So you have the units are in minutes, which is what you want because that's time. So Olga will finish in 60 minutes. All right, now you do the same thing for Vanessa. So for Vanessa, again, you use d equals r times t. And you want to look for t. So t is going to be equal to d over r. So in this case, it's going to be 4,000 meters again. And this time her rate is 200 meters a minute. So the zeros cancel out. 40 divided by 2 is just equal to 20. And again, meters cancel out. The denominator goes into the numerator. So the time will be 20 minutes. All right, and that's for Vanessa. So she'll be 4 minutes behind. So now we have to use d equals rt again for Vanessa because she's 4 minutes behind. So basically at the moment Olga completes the race at the 16th minute mark, Vanessa still has 4 minutes to go. So now her time is going to be 4 minutes. Her rate is going to be 200 meters a minute. And this time d is equal to r times t, which is equal to 200 meters per minute times 4 minutes. Minute cancels out and you have 800 meters. So she has 800 meters left to run. And here, you know that the track is 200 meters lap. A lap is 200 meters. And she has 800 meters left. You know that 200 times 4 is 800, so you also have to times 4 on the other side because this is a rate. 1 times 4 is 4 laps. So she still has choice C, 4 laps left to run. Right, so the answer here is going to be choice C. Again, it's just d equals rt. And you do that for Olga and Vanessa. All right, next for number 6, in the figure above, if AC is equal to DC, mark that up. What is the measure of angle ABC? All right, so here, triangle ACD is an isosceles triangle because two sides are equal. So that means that the opposite angles are going to be equal as well, the ones that are opposite from the two equal sides. So here you know that one of the angles is 120. So if you do 180 minus 120, remember a triangle, 3 sides add up to 180. You have 60 left, and 60 divided by 2 is 30 because they're two equal angles. So each of these will be 30 degrees. Now, once you know that, then you can go to the top triangle because this is a right angle here, which means it's 90 degrees. You can do 90 minus 30, and that will give you 60 degrees for this angle. And it turns out that angle BCA is also 60 because this 120 plus this 60 needs to be 180. So to figure out this angle, that's 180 minus 120, which is also equal to 60. So that means that the last angle B has to be 60 degrees as well. So it's a 60, 60, 60, or an equilateral triangle. The sum of, or the measure of angle AABC is right here. That's 60 degrees, choice D. The other way to do this is, once you know that this angle is 90 degrees and this angle is 30 degrees, you know that this is a 60 because it has to be a 30 60, 90. Triangle. All right, next for number 7 on the board for a certain game. The first square is blue, then the following squares are a repeating pattern of orange, red, green, yellow, gray, blue. Orange, red, green, yellow, gray, blue, etc., etc. What's the color of the 97th square on this board? All right, so here you just have to look for the pattern. So it's blue, then orange, red, green, yellow, and then gray. And then repeats blue, orange, red, green, yellow, gray, etc., etc. So it repeats after every 6. So one set is equal to 6 colors. So what you want to do, you don't want to count all the way up to 97. If you do 97 divided by 6, if you divide, you get 16 remainder 1. And here we actually care about the remainder. The 16 means that you have 16 sets of 6. So that's equal to 96 colors. But you have 1 left over. That means that after you go through the 16 sets, it's going to be gray as the last one. And because you have 1 left over, you have to count the first one in the set. So when you count forward, you just count the first color in the set. That's going to be blue, choice A. In other words, the 96 tile is going to be gray. The one that's left over will restart the new set. You won't go through the full set because you don't have 6. You only have 1. So when you jump 1 step, it's going to be blue, which is choice A. Okay. Next for number 8, a system for choosing a winning lottery number begins with a computer-generated random positive integer less than 25. Remember, integer is a whole number. Now you had to assign this value to the variable x, and then the computer uses the following set of instructions to determine the winning lottery number. So you got to add x to the greatest even integer less than x. If it's even, you got to triple it. If it's odd, you have to double it. Step 3, if it's the result in step 2 is at least 11, subtract 9. If it's not at least 11, leave the number unchanged. In step 4, multiply by 3. And step 5, assign the result of step 4 to the variable y. You want to know which of the following must be true. All right, so I had to go through all these steps here. So you have a couple of things here. One says y has to be even. So you want to see, well, which one will make this even? You just want to substitute in different numbers until you get, let's say, even number and odd number. So let's just substitute in something easy. Let's say 1. So here, add x to the greatest even integer less than x. Well, the greatest even integer less than this is 0. So 1 plus 1, or excuse me, 1 plus 0 is just 1. So nothing changed. For step 2, if it's even, you got to triple it here. The result is odd, so you double it. This turns into 2. And now this is not at least 11, so you have to use this rule. You leave it unchanged. And then multiply by 3. So you have to reach 6. So here, if we choose 1, it's even. It doesn't have to have at least 2 digits, so we can eliminate that. Because it says it must be true. We disproved Roman numeral number 2. It doesn't need to have 2 digits. Our winning number was 6, which is even, and it's also divisible by 6. But it's not 2 digits. So all the choices with a 2 in it are wrong. So C and D are wrong. All right, then you just try a new number, like the number 2. All right, so if x is equal to 2, here you just add x to the greatest even integer less than x. Well, that's just 0 again, because only 0 and 1, only 0 is the even number that's smaller than this. Now this is even, So since it's even, you got to triple it. You got 6. Now this is not at least 11, so leave the number unchanged. Then you multiply by 3, you get 18. All right, so again, it's still even and divisible by 6. Then you try a new number. Let's try 3. So here, when you add x and even integer less than x, this is 3 plus 2, which will be 5. And now it's odd, so you double it, which will turn this into 10. All right, now this is not at least 11, so leave it unchanged. And times 3, you get 30. All right, so we pretty much did a lot of these different rules. The only one we weren't able to do yet was this one, to subtract 9 from that number. Now, the next one we can try, let's say 4. We'll hopefully be able to use that final part. And maybe we'll have an even or an odd, or something that's not divisible by 6. All right, so you have to add x to the greatest even number less than x, which is 2. So 4 plus 2 is 6. Now here this is even, so you triple it to turn it into 18. And now here you can finally subtract 9 from that number because it's greater than 11. So when you subtract 9, you get 9. And then you have to multiply by 3, you get 27. All right, so now 27 is not even, and it's not divisible by 6. So we can eliminate 1 and 3. The answer has to be choice A, none of the above. So sometimes you can get an odd number like 27. All right, so for number 8, the key here was just to guess and check. All right, and here's the summary for this first page. All right, next, number 9, which of the following, zoom in, which of the following is a graph of y equals x squared plus 2x minus 8? All right, so here, what you can do is to look at this parabola, and when you have a parabola, y equals ax squared plus bx plus c, some of these coefficients, a, b, and c, will actually tell you a lot of information about the graph. You always want to start with the constant, which is c. So c is the y-intercept. So it's where it crosses over the y-axis. In this case, it's -8. So the y-intercept is negative, so it needs to cross the the y-intercept below the x-axis, which for choice A, that's true. For choice B, it's above. So the y-intercept is positive here, which is wrong. Same for choice C. The y-intercept is a positive number, which can't be correct. And same for choice D. The y-intercept here is also positive, so that's wrong. And for choice E, the y-intercept is also positive. So again, that is wrong. So from there, we actually use process of elimination. It has to be choice A. Now, the other thing you can do is to look at A. Now, if A is positive, the parabola will look like a U shape. It's going to hold water. Whereas if A is negative, it's going to be upside down. So we know that since A is positive, it can hold water. It's going to be a U shape as opposed to an upside down, like an N shape. All right, and then last but not least, you can also use the axis of symmetry. So the axis of symmetry, this is where these parabola is symmetric, and of course that x equals -b over 2a. So in this case, it will be, since b is equal to 2 and a is equal to 1, -b over 2a will be -2 over 2 times 1, which is -1. So it should be a little bit off axis here, but I didn't have to use that. The answer has to be choice A here. right, next for number 10. Newly hired employees of Bag of Burgers must complete a training period. During this period, they earn a training wage of $10 an hour, which is 20% less than the standard wage. After they complete the period, employees who work more than 40 hours a week earn an overtime wage that is 50% greater than the standard wage. How much is the overtime wage? All right, so you know that the training is $10, and this $10 is actually 20% less than the standard rate. So 20% less than means that you have the standard rate, which you can call R, and you got to subtract 20%. That's going to be equal to the training rate. So if you take 20% away from R, that means that the training rate is 80% of the standard rate R. So the training rate is 10, and that's going to be 80% or 4/5 times R. Remember, 100% minus 20% means 80% left. So that's 4/5. And now to get R by itself, you multiply both sides by the reciprocal, which is 5/4. You can cross cancel everything on the right side. So you just get R isolated. And that's going to be 50 divided by 4, which is $12.50 an hour. So the regular rate is $12.50 an hour. Now, we're not done yet because you want to know the overtime rate, and overtime rate is 50% greater than the standard rate. So now you got to take $12.50 plus 50%. So half, 50% is half. So 50% of $12.50 is just 1/2 times 12.5, which is equal to 6.25. You got to take this and you got to add it to $12.50. So add everything up, you get the overtime is 18.75. And that's choice E. All right, so to do this percent question, you have to rewrite the equations, and you have to multiply by the reciprocal often to isolate the variable. All right, next for number 11, if 10x is equal to 40 times y, then what's the value of x divided by y? All right, so here to get x divided by y, you want to move the variable y on the left side, so you can divide by y. And you want to get rid of the 10 on the left side, so you want to divide by that as well. So then x over y is going to be equal to 40 over 10, or just 4. All right, next for number 12, Ginny ran 186 yards. How many feet did she run? We know that 1 yard is equal to 3 feet, and she ran 186 yards. So here you do 1 times 186 to give me 186. So you also have to multiply by 186 on the other side. So we do 186 times 3. You get 558. And that's the answer here. You just multiply by 3. All right, and here is the summary for this page. All right, next for number 13, if 10a plus 4b is equal to 32 and 9a plus 2b is equal to 24, what's the value of a plus 2b? All right, so here you have a system of equations, which means you have 2 equations and 2 variables in this case, which means that you can solve for each of these. Now, fortunately, we don't actually need to solve for a or b. We actually just want a plus 2b. And if you look at the coefficients here, we can actually get to that by subtracting the equations. Normally, you would use substitution or elimination, but that takes way too long. You don't have to do that here because this question, the way this question is written, it actually allows you to get to the answer pretty directly. If you stack both of these and as if you were doing an elimination, if you subtract these 2 equations, you get 10a minus 9a is just equal to a. And then 4b minus 2b is equal to 2b. You have to subtract everything on the second row. You have 32 minus the 24. You get 8. And that gives you exactly what you're looking for. A plus 2b has to be equal to 8. So you don't need to solve for A or B here. Just a shortcut. For other questions, though, you'll have to either isolate one of the variables to do a substitution, or you have to use the lowest common multiple to eliminate one of the variables for the elimination method. But here we could avoid all of that because the coefficients really worked out for us. All right, next for number 14. In the figure above, the circle is tangent to the x-axis at point C, and it's tangent to the y-axis at point A. What's the value of B? So here, when you have the circle that's tangent, when you have a circle that's tangent to a line, it means it touches at one point. Now, when it touches at one point, one of the properties of a tangent line to a circle is that you can make a right angle to the radius at that point. And that's just one of the properties of tangency. So from the center going to point A, it's a right angle there. And that's just what tangent means. So then you have another one here to the x-axis. Okay, you have another right angle. You have another one going to B. All right, so here you want to know the value of B, which is the y-coordinate of this point up here. So you can actually figure out the radius. So here, if you know that A is 0, 2.3, that means that this part has to be 2.3. The origin to A is 2.3, which is going to be the same distance from C to the center because they're all right angles. You made a square. So that means that the radius is equal to 2.3. So for point B, you're going to have to add the 2.3s together. So point B will actually be 2.3, 4.6. So the value of B is 4.6. It's by using the tangency here. Next one, number 15. In the sequence of numbers above, the number 2, 5, and 7 repeat in that order indefinitely, which means it goes on forever. What is the sum of the 12th and 91st terms of the sequence? So we've seen this question before. The pattern or the set is 3 numbers here. So every 3 numbers, it will be 7. So the 3rd number is 7. The 6th number is 7. The 9th number is another 7. The 12th number, which is what we need, is also 7. So that's sort of the key here. I just want to divide by 3. So the 12th number is 7. To get to the 91st number, you don't want to write the set out 91 times. You will do 91 divided by 3. All right, and you have a remainder of 1. And we don't actually care about the 30. The 30 just means you have 30 full sets when you get to the 91st term. The 1 means you just have to count 1 forward. So after 90 numbers or 30 full sets, that's going to be a 7. You'll have to count the first one, which will be a 2. The 90th term will be a 7. The 91st will be the number 2 again. So the sum of 7 and 2 is 9. So that's the answer for number 15. All right, next for number 16, BC is the hypotenuse of the right triangle ABC. If AC is equal to 3 and BC is equal to 6, what's a measure in degrees of angle B? All right, so you have a right triangle, so I'll just draw your right triangle here. And BC is the hypotenuse. The BC here, so A has to be that right angle. So AC, you know, is 3. All right, so figure out drawing scale. BC is 6. Let me draw it a little better. All right, so here you have AC is equal to 3 and BC is equal to 6. That's the hypotenuse. And you know it's a right triangle. Here you can actually figure out the last side using Pythagorean theorem, or you can use one of the special right triangles. But we can always use Pythagorean, which states that a squared plus b squared is equal to c squared. So here, you'll have to do 3 squared plus, you can call that b. B squared, that's going to be equal to 6 squared. So 3 squared is 9, plus b squared is going to be equal to 36. Then you subtract 9 on both sides. You get that b squared is equal to 27. And then if you do the square root on both sides, you get that b is equal to the square root of 27. And to simplify that, you would find the biggest perfect square factor, which is 9. And you can split this into 2 pieces, and that's going to be equal to 3 root 3. And here, if you see this triangle in which the sides are in the ratio of x, 2x, and x root 3, this is your 30, 60, 90 special right triangle. So you know that angle B has to be 30 and angle C has to be 60 degrees. So the measure of angle B will be right here, equals 30 degrees. So we can use Pythagorean, or we could just use a special right triangle here, this 30, 60, 90. All right, next one, number 17. If 8 raised to the y power divided by 2 raised to the x is equal to 4, what's the value of 3y minus x? So here we have 2 exponents here being divided. So we can't actually do anything unless the bases are equal. So we have to rewrite them in the same base. Fortunately, 8 can be rewritten in the base 2. 2 raised to the third power is equal to 8. So you'll replace the 8 with 2 raised to the third power. And then you'll do some of the laws of exponents. So instead of 8 raised to the y, it turns to 2 cubed raised to the y power divided by 2 raised to the x is equal to 4. And now here, you have a power to a power, which is this law of exponent that states that b to the a raised to the c is equal to b to the a times c. So you have to multiply the exponents, and that's going to turn to 2 raised to the 3y power. And then you're still dividing by 2 raised to the x. That's equal to 4. And now we can use the next law of exponents that allows us to subtract those exponents. B to the a divided by b to the c. When you divide 2 exponents with the same base, you're going to want to subtract the exponent. So that's the second law here that we're going to use. And you're going to have to do 3y minus x, which is exactly what you're looking for. So 2 raised to the 3y minus x is equal to 4. And 4 you can rewrite as 2 squared. And what this allows you to do is to keep the exponents. You know the exponents have to be equal because the bases are the same now. And they're both equal. So you know that 3y minus x has to be equal to 2. So again, the key here was to use this law of exponent. It says when you divide 2 exponents with the same base, subtract. When you do power to a power, you have to multiply. So again, the goal is to rewrite with the same, rewrite exponents with the same base. And we can turn the base of 8, the base of 4, into a base of 2. All right, next for number 18. If a and b are distinct integers such that a times b is less than 1 and b is not equal to 0, what's the greatest possible value of a divided by b? Right, so here they're integers, which means they're whole numbers. So like -2, -1, 0, 1, 2, etc. And they're distinct, which means they have to be different. Now, a times b has to be less than 1, which is kind of weird. So that means that you can't have one of them equal to 0. So if you want to make one of them less than 1, or they have to be whole numbers, here you're going to have a couple of different possibilities. So if you make one of them negative, for example, that's going to turn this fraction negative, and you don't want that. So it could be negative. For example, a is -1, b is -3, and a times b, or sorry, not -3, if you make it +3, for example, a times b will be equal to -3, which is definitely less than -1, but a divided by b will be -1/3, which will be negative. So if you make one positive and one of them negative, you'll always have a negative fraction. So the other way, the only other possibility to get a bigger fraction is, instead of making b equal to 0, we can make a equal to 0. And then b could be whatever, like 10. In this case, a times b is equal to 0 times 10, which is equal to 0, which is still less than 1. So the first part is satisfied. And if you do a divided by b, that's going to be 0/10, and that's 0, which is going to be greater than any negative number. So the answer here has to be 0. You can't come up with a positive number, because if you have two positive integers and you multiply them together, the product will always be greater than 1. And in order to make one of them less than 1, one of them has to be 0 or negative. And 0 will give you the biggest fraction, because negative numbers are smaller than 0. All right, next for number 19, the yearbook staff must assign 4 distinct photographs, 1 photograph per page, to 4 different pages. How many different assignments of photos for the pages are possible? So this is your counting principle, or your tree diagram. So you have 4 different pages. So you have page 1, page 2, page 3, and page 4. And let's say you have the photos A, B, C, D. Well, since you can only put 1 photograph per page, and they're all different because they're distinct, that means that for the first page, you have 4 different options for pictures. But once you pick one for the first page, you will have 3 options remaining for the next page. And then for page 3, you will have 2 pictures remaining, and finally have 1 remaining. And here for the counting principle, you always want to multiply. So when you do 4 times 3 times 2 times 1, you will get 24. So there will be 24 possibilities. The other way to prove this is by using a branching diagram or tree diagram. You branch out 4 times for pictures A, B, C, D. Then for each of these branches, you can only branch out 3 times because you chose the first picture. So you have B, C, D left. And for each of those branches, you can only branch out twice because you only have 2 pictures left. And then you can only branch out 1 more time. All right, next for number 20. The average of 5 positive integers is 20. Now, if 4 of the integers are less than 10, what is the least possible value for the remaining integer? All right, so the average is 20. So remember, average is the total divided by the number of data. So in this case, we have 5 numbers, and the average is 20. So it's going to be total divided by 5. And here, you can multiply both sides by 5. And that gives you, the total has to be 100. Now, you know that 4 of the integers are less than 10, and you want to know the least possible value for the remaining integer. So in other words, you want to minimize the last number. So that means that the other four, you're going to want to maximize them. Now, because they all have to be less than 10, the biggest number, a whole number, a positive whole number, less than 10 is 9. So all of those will have to be 9. And 9 times 4 is 36. And then the total has to be 100. So 100 minus 36 is going to be 64. So that means that the smallest possible value for the last number has to be 64. All right, and here's the summary for this page. All right, next for number 1, if 8 minus w is equal to negative 2w minus 8 plus 5w, then w is equal to. So here you want to combine like terms. You can add w to both sides to put everything on the right side. So I will give you 8 is equal to negative 2w plus 5w plus w. So that's going to be 6w minus 2w or 4w. You still have that minus 8. Then to isolate the w's on the right side, you're going to have to add 8 to both sides. And that'll give you 16 is equal to 4w. And the final step is to divide both sides by 4 to get w by itself. And that gives you w is equal to 4. Choice B. All right, next for number 2, William keeps an inventory of the fruit he displays in his grocery store. The table above accounts for the number of pieces of fruit in a display as well as the number of displays in the store. According to the table, how many total oranges and bananas are displayed in the store? All right, so here you have this chart that tells you the number of fruits at a display and the number of displays. So here this is otherwise known as a frequency table. For frequency tables, you have to essentially multiply and add. So if you want to know the total oranges and bananas, so you don't care about the apples, for the oranges, you have to do 13 times 3, which is equal to 39, and then 50 times 5, which is equal to 250. Then you want to add them up, and that's going to give you 289, which is choice D. All right, next for number 3, in triangle MNO above, what's the value of x? So here to find the value of x, we can first use the fact that supplementary angles add up to 180 degrees. So supplementary angles, just a straight line, and that equals 180. So you can do 180 minus 100, which is equal to 80 degrees. So that's this angle here. And on the other side, you can do 180 minus 120, which is equal to 60. And then the next piece of info you can use is that a triangle adds up to 180 degrees. So here you have 80 and 60, which means you already have 140. So if you do 180 minus 140, you will get 40 degrees left, and that has to be x. So that's choice B. All right, next one, number 4. There are 140 people in a room. 12 of these people leave. What percent of the original group would remain if another 9 people leave? So there were 140 people, 12 people left. So you subtract 12. That's going to give you 128. And then another 9 people will leave, so you subtract 9. That's 119. So this is the part. And what percent of the original group? Of represents the whole. And the whole here is 140. So here is just part of a whole, which is 119 divided by 140. And you want to multiply this by 100%. So 1 to the zeros will cancel out. And then the 10 and the 14 has a common factor of 2, so you get 5 and 7. You want to try 119 divided by 7. See, it's perfectly equal to 17. So you cross cancel the 7 and 119. You have 17 left. So it just becomes 17 times 5% or 85%. So choice E, 85% remain. All right, so here in the graph, in the graph above, H represents the average number of hours per day spent watching television, and S represents the score on the final exam for the 12 students in Mrs. Haskell's biology class last semester. Which of the following best describes the relationship between H and S? So H is the hours watching TV, and S is the score on the test. So you can kind of see that if you do the line of S fit, there's a downward trend. So that means that as the X, or in this case the H, as the hours increase, the Y value, which is the scores, decrease. So the more hours you spend watching TV, the day before the test, your test score will go down because you're probably not studying that much. So this is called, choice C, an indirect relationship. Indirect means that as one variable goes up, if H goes up, S goes down. And vice versa. If H goes down, then S goes up. So that's what we have here. It's not a direct relationship. For choice C, a direct relationship would actually have a positive slope where X goes up, Y also goes up. So that's direct here. This is indirect. Because X goes up, Y goes down. So it has a negative slope. All right, and here's the answers for this page. All right, next for number 6. In a standard deck of cards, there are 52 total cards divided equally into 4 suits: clubs, hearts, diamonds, and spades. There are no jokers in the deck. If a diamond is selected at random from the deck without replacement, what's the probability that a second card drawn from the same deck is not a spade? All right, so you have 52 divided by 4, so you have 13 of each suit. Now, a diamond got selected without replacement, so now you only have 12 diamonds. And the rest are just 13, so you have 51 cards left. Now you want the probability that the second card drawn is not a spade, so that's the part. So the part is not spade, and the whole is just a total. So the total is now 51, and now you want to figure out how many cards are not spades. Well, you have 12 diamonds, you have 13 hearts, and you also have 13 clubs. So if you do 12 plus 13 plus 13, you will get 38. So 38 cards are not spades, so the probability is 38 over 51, or choice D. All right, next for number 7. If a squared divided by b is equal to a to the 4th divided by x, what's the value of x in terms of a and b? So here, when you have two fractions being equal to one another, first thing you want to do is cross multiply. So that will be a squared times x is equal to b times a to the 4th. You want to know the value of x in terms of a and b, which means you have to isolate or get x by itself. And you can do that if you divide both sides by a squared. And from here, you can actually use the law of exponent that states that when you have two exponents with the same base and you're dividing, you're going to want to subtract the exponents. And here the b doesn't really count here because it's not one of the like terms. So the a to the 4th divided by a squared will turn into a to the 4 minus 2, or just a squared. You still have that b being multiplied in the numerator. So it's still like b over 1, or just b. So you know that x will have to be b times a squared, or choice C, a squared times b, just a commutative property. Again, here you have to use this law of exponent. We divide two exponents of the same base. We're going to subtract the exponents. All right, next for number 8, if a is equal to 4b is equal to 5c, what's the value of 60a minus 28b in terms of c? All right, so here you can, these aren't like terms yet, so you can make them like terms if you replace 4b for a. So it'll turn into 60 times, you'll substitute in 4b and minus 28b. So 60 times 4b is 240b minus 28b. You have to do 240 minus 28. I'll give you 212b. Now, you want to also rewrite in terms of c, and now is where you use the second half of the equation. You know that 4b is also equal to 5c, and we divide both sides by 4. Then the b is equal to 5 c over 4, and this is what you'll substitute in for b. So that will give you 212 times 5c over 4, and here you can cross simplify the 4 and the 212. So do 212 divided by 4, you get 53. So that's going to be 53 times 5, and 53 times 5 is 265 times c, and that's going to be choice E. All right, next for number 9, the 4 numbers above need to be put into descending order from left to right. The arrangement can only be changed in 2 ways. Numbers with 1 or more numbers between them can be switched with each other, or the numbers in the furthest right position can be moved to the furthest left position. What is the least number of changes necessary in order to complete this? So you want to move these numbers to descending order, which means it's going down. So you'll have 67, then 30, then 15, then 10. So that's the end product. But you can't just move it this way. Move it in a couple of ways. So the first way is numbers with 1 or more numbers between them can be switched with each other. So for example, if you want to put 67 first, you can swap 67 and 30. Because they have a number between them, and they could be switched. And so can 15 and 30. And then the other way is the numbers in the furthest right position can be moved to the furthest left. So the number all the way on the right can be moved to all the way to the left. So here, essentially try to move the numbers so that you end up with 67, then 30, then 15, then 10. All right, so you want to figure out how many different ways can you complete this. All right, so here you can make, let's say the 10 and the 15 you can swap. So that'll be 30, 15, 67, and 10. And you can also swap the 67 and the 30. And you can't switch the 15 and the 30 in the middle because they're right next to each other. They can only be switched if there are numbers in the way. So that's going to kind of mess up the 67 and the 10, so you probably don't want to do that. All right, so then the other option is to somehow put, let's say if we were to put the 67 first, or actually we can put the 15 first. So then it'll be 15, 30, 10, 67. And then 67, you can switch to the first position. And from here, you can switch and again, we actually end up with the same issue, so that's not good. So I have to use some combination of both of these. So after using combination, for example, if you were to, let's say, switch the first and the last one, 30 and 15, using the first rule, you'll have 15, then 10, 67, and 30. So that makes 15 to the left of 10, which is good. And then we can actually move the last number to the first position 2 times. So then 30 will move to the front, and that'll be 30, 15, 10, and then 67. And then we use the second rule again to move 67 to the front, and that'll give you 67, 30, 15, and then 10. So it took 3 swaps, which is choice B. So again, for number 9, you just guess and check and follow these 2 rules. All right, next for number 10, PR is tangent to a circle with center O and radius of 4 at point Q. If the measure of POR is 90 and OR is equal to 5, OP is equal to 20 over 3, then PQ is equal to 2. All right, so here you want to draw a diagram. So you have a circle with center of O, and PR is tangent to this circle, and radius of 4 at point Q. So PR is tangent to this, which means that it has to meet at a right angle. Now the measure angle POR is 90. All right, and then we make a couple of changes. The center is actually O, not Q, and point Q is actually here. All right, so here the measure of angle POR is 90 degrees. So let me redraw that so it's a little more to scale. Now OR is equal to 5, and OP divided by, OP is equal to 20 over 3. I don't know what PQ is equal to. All right, so here we have this right triangle. So we could do Pythagorean, because PR is the hypotenuse. So for Pythagorean, it's a squared plus b squared is equal to c squared. So in this case, 5 squared plus 20 over 3 squared is equal to c squared. 5 squared is 25. 20 over 3 squared is 400 over 9. That's equal to c squared. You can rewrite 25 if you multiply by 9 over 9. This is going to be 225 over 9 plus 400 over 9 is equal to c squared. And 400 plus 225 is 625 over 9. So if we do the square root on both sides, both the numerator and the denominator are perfect squares. C would be equal to 25 over 3. All right, so this is actually, if you rewrite the 5 as 15 over 3, this is your 15, 20, 25, 3, 4, 5 right triangle. Because the numbers actually worked out really well. All right, so the other part is that you have this tangent line, which makes a right angle. So you want PQ, so you want to use this triangle on the left here. So you use this 4, this 20 over 3, which is now the hypotenuse. And this part we can just call x, which is what we're looking for. So in this case, you want Pythagorean again. You have x squared plus 4 squared. These are the two legs, is equal to 20 over 3, the hypotenuse, squared. That's x squared plus 16 is equal to 400 over 9. 16 you will rewrite as, do 16 times 9. That's 144. So 16 you'll rewrite as 144 over 9. So if you subtract 144 over 9 on both sides, you get that x squared is equal to 256 over 9. And then when you do the square root, you get that x is equal to the square root of 256 over 9, which again, two perfect squares. That's going to be 16 over 3. And that's choice C. So 4 you can rewrite as 12 over 3. This is actually your 12, 16, 20, 3, 4, 5 right triangle as well. So there's a 3, 4, 5 right triangle inside this 3, 4, 5 right triangle. Or a variation of the 3, 4, 5 triangle. One of the variations of this triplet. So again, here the key is just using Pythagorean twice. And then drawing the diagram first. All right, and here's a summary for this page. All right, next, so you have this g of x is equal to 1/2 times x squared divided by 3, which of the following is an integer. So you just have to substitute in, this is your function. So it's your input-output machine, you put x into this function called g, you get g of x out, and you have to do these three things. So remember order of operations, so you got to square x first. Then you multiply by 1/2, and then step 3, you divide by 3. So those are the 3 steps in G. So we'll just go through all the choices. So G of 3, for example, will be 1/2 of 3 squared divided by 3. So that's 1/2 of 9 over 3. And that's 1/2 of 3, which is 1.5. That's not a whole number. Remember, an integer is a whole number. All right, so then try 4. That's going to be 1/2 of 4 squared divided by 3. So that's going to be 1/2 times 16 over 3. And that's 8 divided by 3, which is not a whole number. Then you try choice C, which is 5. That's 1/2 of 5 squared divided by 3. It's going to be 1/2 of 25 over 3. And here you can see it's already not a whole number because 25 can't divide by 3. And try 6. You have 1/2 of 6 squared divided by 3. It's going to be 1/2 of 36 over 3. That 36 is a multiple of 3 and it's also a multiple of 2, so you know it's going to work. Half of 36 is 18, and 18 over 3 is 6. That's a whole number, so the answer has to be choice D. And then here we try choice E, 7. 7's not going to work. That's not divisible by 3. So 1/2 of 7 squared divided by 3. 49 can't divide by 2 or divide by 3, so it can't be a whole number. So for number 11, just have to substitute in. All right, next for number 12, how many distinct integer values of g of x are there that are less than or equal to 150 when x is a positive integer? So you want to set that equation less than or equal to 150 as the output. Remember, g of x is the output of this input-output machine. So you have to use that rule. You want g of x, which is equal to 1/2 x squared over 3, has to be less than or equal to 150. So here, I'm going to solve for inequality. To solve just like regular equations, what you do to one side, you got to do to the other side. Times 3 on both sides, you got 1/2 of x squared is less than or equal to 450. Then if you double both sides, get that x squared is less than or equal to 900, which you could then do the square root. And x has to be less than or equal to the square root of 900. All right, so here, 900 is 30 times 30. So here you want to know how many distinct integers of g of x are there that are less than or equal to 150 when x is a positive number. So here you have a bunch. There will be 30 numbers less than or equal to 30. Remember, it includes 30. So you start with, and they have to be positive. Start with 1, then 2, then 3, then etc. all the way up to 30. So this is not actually choice A, it's choice D. All right, next one, number 13. If g of x is equal to 24, what's the value of x squared minus g of x? All right, so g of x is equal to 24. So you set 24 as the output of this. That's 1/2 x squared divided by 3. And set this equal to 24, so this is the output. And you want to know what the input x is. So you just work backwards. You would have to multiply by 3 on both sides. You get 1/2 of x squared is equal to 24 times 3, which is 72. And then you can multiply both sides by 2, the reciprocal, to get rid of the 1/2. Get x squared is equal to 144. And from here, if you do the square root on both sides, you get that x is equal to 12. Now, once you know that x is equal to 12, you'll have to substitute in 12 for g of x again, and x squared. Now, you already saw for g of x. If you substitute in 12, you'll just get back 24. Because you plug in 12 into this function g, you get g of 12, which is equal to 24. Like we just solved for that. So g of x is equal to 24, but x squared is 144. So you'll want to do 144 minus 24, which is equal to 120, which is choice B. All right, next for number 14, if y is equal to ax plus b and y equals cx plus d, our equations are parallel lines, then all the following must be true except, so the key here is parallel, and parallel lines have the same slope. So the slope in y equals mx plus b in slope-intercept form. This is a slope-intercept form of a line. The slope is actually right there, is the m. It's the coefficient of the x. So it's this a and the c. So a has to be equal to c. So choice A has to be true. Now if a is equal to c, we don't know if they're equal to -1. They actually can't be equal to -1. If the slopes multiply to form -1, that wouldn't mean that they are negative reciprocals. This would actually be true for perpendicular lines. So choice B is probably not true. But if you go through all the choices, A and C are the same. So for choice C, for example, A squared over C squared is just going to be 1 because A is equal to C, so then A squared is equal to C squared when you square both sides. So A squared over C squared is just 1 because the numerator is equal to the denominator here. So C is true. Again, you're looking for one that is not true. So again, for the next part, C squared and the square root of C squared is just equal to C. The absolute value of A is just equal to C because A is equal to C. It doesn't really matter if A is a positive or negative. When you do C squared, it always turns positive, and the square root of a positive number is always positive. So choice D is just the positive versions of these. So that's always true. And for choice E, that's always true as well. If it's positive times positive, it's of course going to be greater than 0, but even negative times negative. So both lines are negative slope. But because they're parallel, negative times negative is still positive. So E is also wrong. The answer has to be choice B. Again, parallel lines have the same slope. All right, next for number 15, a circle with center O has a diameter of 2 times the square root of 2. If the square KLMN is inscribed in the circle with all 4 of its vertices lying on the circle, what's the perimeter of triangle KOL? I'll draw this diagram here. So you have this circle and you have this square inside. And it's inscribed, which means that it's perfectly inside this circle. All right, whatever. And here the diameter is 2 root 2. So the key here is that the diameter is equal to the diagonal of the square. If the square is inside the circle. So it's 2 root 2. And remember, the diagonals bisect each other, so each part is root 2. Now you want the perimeter of KOL. So KOL will be one of these 45, 45, 90 triangles. Over here. Remember, the diagonals bisect each other and they're perpendicular because it's a square. And it turns into a 45, 45, 90 right triangle. So to get the perimeter of this, each side is equal to root 2. Remember, you get that root 2 by doing the diameter divided by 2. And then the hypotenuse is xxx root 2 for a 45, 45, 90 right triangle. You can also use Pythagorean, but for 45, 45, 90, that's Gauss's right triangle. That's a ratio. So then x is equal to root 2. So then here, root 2 times root 2 is equal to 2. So the perimeter will be 2 plus root 2 plus root 2, or choice D, 2 plus 2 root 2. Because root 2 plus root 2 becomes, they're like terms. This is 2 times root 2. All right, so again, the key here is the 45, 45, 90 triangle as the shortcut. If you don't want to solve it that way, you can also use Pythagorean. And then the other piece of info is that if you have a square, the diagonals all bisect each other because a square is also a parallelogram. Now, the diagonals are also perpendicular because a square is also a rhombus. All right, and here's the summary for this page. All right, thank you everyone for joining, and I'll talk to you guys in the next one. All right, bye everyone.